Hello everyone, myself Tejashwi Kumar and welcome to you in my channel. So today we are going to start one of the most important chapter of chemistry, a carbon and its compound. And this chapter is particularly for class 10th, right? Since this chapter is very important chapter for your term 2 examination, so without wasting time, let's start. So see, the first and foremost things that has to be come in your mind when you will hear the name of the chapter, carbon and its compound is, what is carbon? See, the chapter only insists that carbon and its compounds, So it's very important for us to know about what is carbon, because each and every topic there is carbon. See, in class 11, when you will go in class 11, you will study about inorganic chemistry, which is if your concept is clear about this carbon and its compound, there won't be any problem in class 11th. See, now let us see what is carbon. See, carbon is an element as well as non-metal. Carbon is an element as well as non-metal. What is it? Carbon is an element as well as non-metal whose atomic number is 6 and valency is 4. What it is trying to say is that, now let us understand what it is trying to say us. Carbon is an element. Carbon is an element. What is element? Element is any substance that is made up of only one type of atom. Element is any substance that is made up of only one type of atom. See, can you say that carbon is also made up of only one type of atom? Because carbon is an element, so therefore carbon is also made up of only one type of atom. Clear? Carbon is also made up of only one type of atom. Right? So now is it clear that carbon is an element? See, one more thing, that I am assuming that your old concept of your class 9 chapter, atoms and molecules, atomic structure, is clear, right? I am assuming that. See, therefore carbon is an element as well as non-metal whose atomic number is 6 and valency is 4. So see, one elements table is given, right? One elements table is given in class 9th, or even you can see in periodic table, that there is an atomic number. You can see the atomic number 6 over there. You can see the atomic number 6 over there. Clear? You can see the atomic number. When you will see the atomic number 6, you will find that there is carbon in the elements table. You will find that in the atomic number 6 there is carbon. Now do you have belief that carbon is an element? Very good. Carbon is an element as well as non-metal, Now what is non-metal? You have studied about this in previous chapter. You have studied about non-metal in previous chapter, that non-metal is nothing but which doesn't conduct any electricity. Means when you will try to pass electricity in a non-metal, it won't conduct any electricity, right? And which is non-malleable, means which cannot be converted into thin sheet. And it is non-ductile, means which cannot be converted into thin wire. So simply, carbon also cannot be converted into thin sheet, thin wire, and no electricity can pass through carbon, right? Whose atomic number is 6. I told you, if you will see the atomic elements table, the number 6 of element, you will find that there is carbon. Now, and its valency is 4. It needs to be understood. And its valency is 4. You have studied about electronic configuration in class 9th. You have studied about electronic configuration in class 9th. So what is the if its atomic number is 6, then what is its atomic electronic configuration? Its atomic configuration will be 2, 4. Its atomic configuration will be 2, 4. Means, do you remember that last electron, means outermost cell of any electronic configuration is what it is known as? It is known as what? It is known as valence electron. It is known as valence electron. Clear? It is known as valence electron. So how can we find the valency? We can find the valency of carbon is like this. Valency equal to 8 minus valence 8 minus valence electron. 8 minus valence electron. So valency of carbon is equal to 8 minus, what is valence electron over here? Is 4. Right. So therefore valency of carbon is 4. Is it clear? Is it clear to you? The electronic configuration of carbon is 2, 4, right? And its valence, and how can we find the valency of carbon? We can find the valency of carbon simply by 8 minus valence electron. So 8 is simply an 8, right? What is valence electron of carbon? Is 4. So 8 minus 4, 4. Therefore valency of carbon is 4. Clear? Very good. Now let us see more about carbon. How much percentage it is present on our Earth's crust? See, in Earth's crust has only 0.02%. Earth's crust has 0.02% of carbon in the form of minerals. Earth's crust has 0.02% of carbon in the form of mineral in our Earth's crust. In our Earth's crust, carbon is present 0.02%. Can you see that how much little amount of carbon is present in our Earth's crust? That is also in form of minerals, right? That is also in the form of minerals. Only little amount. Then from this, from first topic, can you conclude that it is means very small amount of carbon is present in our Earth crust? Can you conclude that only small amount of carbon is present on Earth crust? Very good. Now let us, first point is clear. Now let us see to second point. Second point is carbon has 0.03% of carbon dioxide atmosphere. See, what is atmosphere? See, this is basic lecture. This is basic lecture. So I will try as much as possible to give you basic about the carbon, this carbon topic. So see, what is atmosphere? Atmosphere is the blanket of layer, right? The blanket of layer. Suppose this is atmosphere, right? See, the blanket of layer that surrounds the Earth's surface, right? The blanket of layer that surrounds the Earth's surface. Clear? That surrounds the Earth's surface, right? Atmosphere is nothing but it is a layer of blanket that surrounds the Earth's surface, right? See, so in our atmosphere, carbon dioxide, the presence of carbon dioxide, we know that there are three main components. Nitrogen 78%, oxygen 21%, and other gases is 1%. So in other gases there is carbon. There is carbon, and how much percent? Only 0.02%. Only 0.03% of carbon dioxide is present in our atmosphere. Now can you see that only carbon in free state is found in our Earth is 0.02% in free state, means independently, and when it is also existing with other atoms means carbon dioxide. Carbon dioxide means double atom of oxygen. When it will be in combined state, then also the percentage of carbon is lower, right? Is lower. So from this topic also you can conclude that in our atmosphere there are very little amount of carbon. There are very little amount of carbon dioxide present in our atmosphere. Now from this topic you can also conclude that carbon in our Earth's crust, the presence of carbon is very little, very low, and in our atmosphere also the carbon present is very low. Now let us see last part, that is all living things are made up of carbon. All living things are made up of carbon. See, you are going to learn about this. All living things are made up of carbon in your class 11th class, that DNA, it is also DNA is made up of that. What you take oxygen, even there are carbon, right? Even blood cells and many our body is composed of carbon only, right? And we exhale carbon dioxide, and plants take the carbon dioxide. Means, can you see the means how carbon is important? How carbon is important? Just don't think that carbon is only bad. Means we just exhale carbon dioxide. Means if carbon dioxide won't be there, we won't be there. How? Because plant will take that carbon dioxide and they will inhale it. They will take the carbon dioxide and they will inhale it. And what will they exhale? They will exhale oxygen, and we will inhale that oxygen and we will exhale the carbon dioxide. So the interrelationship between plants and animals is going on, right? So therefore carbon dioxide is also very important, carbon dioxide is also very important molecule, right? So just thank to carbon dioxide that from you only we are existing, right? Clear? Now let us see. Now let us see bonding in carbon. Now we will see bonding in carbon. We have learned about carbon has 4 electrons in outermost shell. How? See, we have shown about 2, 4. What is this? This is electronic configuration of carbon. So what is this? Valence electron, means it has only 4 electrons in its outermost shell. This much is clear? Very good. But it neither loses them or nor gains 4 electrons. But it neither loses them or gains 4 electrons. See, on basic part, for any element to satisfy its valence cell, they will gain, they will lose electron, right? They will lose electron or they will gain electron. I'm pretty sure that you have studied about ionic bond in your previous chapter, metals and non-metals, right? What they will do, some elements whose atomic number is 2, whose outermost cell, if its electron is 2, then it will give an element to other metal. See, suppose you take an example of NaCl, right? You take an example of NaCl. You take an example of NaCl. What this NaCl will do? See, Na has how many valence electron? What is the electronic configuration of sodium? It is 2, 8 and 1. 2, 8 and 1. And what is the electronic configuration of what is the atomic number of calcium? It's 2, 8, 7. Its atomic number is 17, therefore its atomic electronic configuration is 2, 8, 7. See, means carbon has 1 electron in its outermost shell. Carbon has only 1 electron in its outermost shell, and chlorine has 7 electron in its outermost shell. So to complete its octet, octet means simply but outermost shell has to be 8 electron, right? And outermost shell can be means to satisfy its valence cell, any element in its outermost shell has to be 0 electron or 8 electron. If it has 0 electron, then it will be known as duplet, and if it has 8 electron, it will be known as octet. So means, this Na atom, right? Na atom can can gain 8 electron, but to be 8 electron, it has to be lost, very, more amount of energy. It has to, for to accept 8 electron, to be 8 electron in its valence shell, it has to lose, it has to gain more amount of electron, and it will lose more amount of energy, right? So what it will do is, see, this is 7, so is it 8 or is it 0? No, it is 7. So it is nearly what? It is nearly 8 only. Means it is nearly 8. So it is easy for the Cl to complete octet, right? And it's easy for NaCl to complete duplet. Clear? So what Na will do? Na will share one electron to what? To Cl. So now what is Na? Na is 2 8. And now what is chlorine? Is, oh sorry, chlorine is 2 8 8. Clear? So is it satisfying? Octet is full. 8 8 is there. So what will it do? So which is a sharing electron, that will be which is, sharing electron, sorry, not sharing, which will lose electron, that will be positive, and which will gain electron, that will be negative. So Na plus Cl minus. See here, clear. So now what about carbon? Carbon has, in its outermost shell, carbon has 4 electron. So what you think? Will it gain or will it lose the electron? Carbon will gain electron or lose electron? So actually carbon, but it neither loses nor gains 4 electron. It won't lose any 4 electron, or it won't gain any 4 electron. Clear? It won't gain any 4 electron, or it won't lose any 4 electron. So now what will it do? One very common question the board asks, that if carbon neither loses nor gains 4 electron, then how carbon complete its duplet or octet? Right? How it will complete its duplet or octet? It's very simple. Now we'll see the question. Why can't carbon lose 4 electrons? Why can't carbon lose 4 electrons? See, here is the answer. Carbon has 6 number of proton and 6 number of electron. See, in class 10 you will also study about number of electron will always equal to number of proton. Number of electron will be always equal to number of proton. See, right? So what is the atomic number of carbon? The atomic number of carbon is 6, right? So number of electron will also be in carbon be 6 only, and in number of proton of carbon will also be 6 only. Is it clear? Very good. Can you see now? 6 in proton has 6 and electron has 6, right? 1 2 3 4 5 6. Sorry, by the way, this is not there. Clear? Very good. Now let us see the answer. If carbon will lose 4 electron from the valence shell, it would require a lot of ionization energy, right? What I said in NaCl, Na plus Na has 281 in its outermost shell. It has 1 electron. So to complete its octet, it will require a lot amount of energy, right? it will require a lot amount of energy. Then you complete 2, 3, 4, 5, 6, 7 and then 8. Means it will require a lot amount of energy. And if Na will share, means if Na will lose electron, right? If it will lose electron, only little amount of energy is used. Clear? As similar to that, if carbon will lose 4 electron, then the valence cell is 4, right? Then in the valence cell, if it will lose 4 electron, then lots of ionization, means lots of energy will be required. And the electron don't want to do more amount of electron, means they are of no capability. They don't have any capability of losing more energy. Only they want to lose low amount of energy. So if it will lose more amount of energy, then will it lose electron? See, more amount of energy is if it will lose electron, then more amount of energy will be used. Then what electron wants to do more amount of energy? Want to do work? Want to do more work? No, it doesn't want to do more work. Clear? It doesn't want to do more work. So therefore it's clear that it is not going to lose any electron, because more amount of energy is used, and an electron doesn't want to do more amount of energy. Clear? Very good. Now, if carbon doesn't lose any electron, then why carbon cannot gain 4 electron? Right? Why carbon cannot gain 4 electron? Then see the answer. It could gain 4 electron forming C4 minus anion. Right? See, which will gain? They will be minus. I told you, Na will lose its electron. Right? Na will lose its electron. Therefore, its what will be its charge? Its charge will be plus, and if somebody will gain electron, then the charge will be minus, negative charge. So if carbon will go, if it could gain 4 electron, means carbon can gain 4 electron forming C4 minus, because if it will gain, it will form C4 minus. But it would be difficult for the nucleus with 6 proton to hold on to extra 10 electron, that is 4 extra electron. Means for sharing electron only, right? If it will gain 4 more electron, right, it would be difficult for the nucleus with 6 proton. Nucleus has how many proton? Nucleus has how many proton? 6 proton, right? 6 proton. So nucleus with 6 proton to hold on extra 10 neutron. See, it has 6 proton, right? And if 4 more electron will be gained, it will be difficult for the nucleus to hold how many electron? 10 electron. 10 electron. See, we'll start from the first. Why doesn't lose any electron? It doesn't lose any electron because in ionization process it will require a lot amount of energy, and it doesn't want to lose more amount of energy. Then why it doesn't gain? There is no need of any energy. It will just sit like this and it will just gain, right? No energy required. But nucleus has 6 proton, and if it will gain 4 more electron, how many? It will be 10 electron. It will be difficult for the nucleus. Means see, this much small rod is there. In that small rod, can 2 truck be gone? That is the space only for 1 truck. Then can 2 truck be gone from there? No, it can't be. It can't be there, right? So it has capability of only 8 electrons. Then how it will form 10 electrons? Right? It has only capability of being only taking 4 electrons. Then how it can gain 10 electrons? Simple. Clear. So now you said it won't gain any electron, it won't lose any electron. Then what actually carbon will do? What actually carbon will do? See, very interesting topic is going to come. Now see, since carbon atoms can achieve the inert gas electron arrangement only by sharing of electron. See, what is inert gas electron? Inert gas electron means whose valency is 0. The element whose valency is 0. And each and every element, when it will be combined either by ionic and either by bond, which we are going to study now, its valency will be 0 only. Either it will be complete, either it will complete its duplet, or either it will complete its octet. So it's always its valency will be 0 in combined state. Clear? And each and every element, when in combined form, wants to be in inert gas electron arrangement. So how carbon actually means achieve the inert gas electron? See, carbon atom can achieve the inert gas electron arrangement by arrangement only by sharing of electron. Only by sharing of electron means carbon atom won't gain any electron, or carbon atom won't lose any electron. Clear? Carbon atom won't lose any electron. So what carbon will do? Carbon will share its electron. Carbon will share its electron, right? Now how it will share? We are going to see in the next lecture. See how it will share. See, carbon has 4 electron. Right? And what carbon will do is carbon will it require 4 more electron, right? So it will share 1 electron to this carbon and 1 electron to this carbon. See, in another lecture your all topics will be cleared, right? Since here you just need to remember that carbon atom just shares its electron, means it neither gains any electron, it neither lose any electron. It will just what? It will just share its electron. Clear? It will just share its electron. And when any element will share electron, there is name for that sharing of electron. New name is there. What is that? That is covalent bond. See, when the atom neither loses any electron nor gains any electron, then if it will share electron, then that sharing of electrons is known as covalent bond. Is that clear? See, in the case of NaCl, Na will lose electron and Cl will gain 1 electron, right? So what is the name of that sharing, gaining or losing of electron? You have studied it in previous chapter. That is known as ionization or ionic bond. When the atom gains or loses electron, that is known as ionization or ionic bond. But when an element share its electron, that is known as covalent bond. So carbon shares any electron? Obviously yes. Does carbon gains or loses any electron? Obviously not. So is carbon an example of ionization? Obviously not. Is carbon an example of covalent bond? Is absolutely true, because carbon will share electron. Clear? Carbon will share electron. So till then, this much. Another lecture of how covalent bond is formed, catenation and tetravalency, and many more is going. This topic will be covered in or your next lecture. So I hope that what I have taught you in this lecture, all your concept is clear, right? So till then, wait for the second lecture. I will make the PPT and I will upload that video soon. So thank you, bye bye, see you in the next lecture.